Hello, everybody. We're just waiting for the 11 o'clock official start time, and then we'll get going. Not long to go now. Not long to go now. Excuse me. In the meantime, you can admire the absolute order of the weather shed down in Falmouth. Not really. Right. I do have tea. Very important thing. Hello, everybody. I'm Simon Rowell. I'm the meteorologist for the British sailing team. And what I'd like to do today is to talk to you about how to get a forecast, and more importantly, how to use that properly during the day. So I'm just going to share my screen here, and we'll start going through a few pictures and slides just to help illustrate a few points. So there you go. Right, so we're talking about forecasting for real life now, because weather forecasts are great, but they rarely survive contact with completely survive contact with reality. So the important thing is to know how to use that to still help you sail, because weather forecasts are, I think, a really important part of sailing, and it's important to know how to use them. I think possibly one of the most important things about using a weather forecast is to use your eyes and use your senses, because if you are a sailor, if you are a regular sailor, then you'll actually know more about forecasting than you think you know. The picture that's on the screen now, for example, that was taken last summer out in Enoshima, which is the sailing venue for the Tokyo Olympics. And I hope you can see it on your screens, but you can just see against the land in the backdrop there, there's horizontal layers of very thin haze. If you look right down at the bottom, you can see a whole bunch of small boats. There's 470 there. There's a whole bunch of stuff just bobbing around, really going nowhere at all. So on this particular day, we were waiting for a sea breeze to come in from the west. And this photo is looking out to the west, and we can see these layers of cloud, these laminations of cloud, and that's a great sign that the sea breeze is actually there. So about half an hour after this photo was taken, we got a reasonable sea breeze. It wasn't very strong, but it was what we were expecting. So I guess the thing I'm going to bang on about today a lot is when you do get your forecast, try and understand what that means, what you're going to see during the day, and then tick that off as you go through the day. Okay, so let's start off then. With what you can do these days, you can get weather forecasts from loads and loads of places. I mean, just today, this was Carol on the BBC telling us what's going on, and there looks to be a big swirl of cloud behind her with Iceland getting very wet. There's Reykjavik there, and a northwesterly over Scotland, and a northeasterly down with us. We're down there in Cornwall, down there. So wherever you are, you would have seen Auntie Carol on the telly if you're watching the BBC. There's also you may not understand these yet, but synoptic charts. This is the one from this morning from the Met Office, and you can see there's a big high pressure system off to the west there. There's Ireland, there's Scotland, England, Wales, and Cornwall, hurrah, down there. So you've got this big high pressure system with the wind circulating around it there. That's the front, which means there's going to be a bit of cloud there. And this funny thing down here, which we don't see that often, that's a convergence line. Means there'll probably be a bit more rain and cloud down there. But anyway, that's the official weather chart, as it were. A good thing to get to know how to use, but it's not that important at this stage in your sailing career. If your parents have the Radio 4 on, you may have listened to the inshore shipping forecast and gone, "Oh, Dad, turn it off, boring." But anyway, you can get information from there as well. A really good source of information is the Met Office website, and this is the forecast for where I am today. And it's according to this, it should be sunny all the way through till early afternoon, to about 1500, and then cloudy after that. How cold is it? How hot is it? This time of year, definitely cold. It's looking to be 9 degrees Celsius, with wind chill down to 6, so pretty chilly. And if we were going sailing today, which we're not for obvious reasons, you'd want to wear decent number of layers of clothing to make sure you didn't get chilly. The wind itself is looking very nice. It's an easterly most of the day, maybe a bit of northern in it. Starting off a little bit breezy, so in the morning we're looking at about 15, 16, 17 knots, gradually dropping off during the afternoon gusting up to maybe the low 20s. So a really nice day on the water. And as you can see from the wind arrows there, everything's pretty steady. It doesn't really change very much at all today. What else can we have? What else can we see? If you want to get a bit technical, you can look at satellite photos of the cloud from above. This is quite useful. This is rain radar, and that's where I am there, just in St Justin Roseland. And here's a bit of rain along the French coast there. That ties in, if you remember on the synoptic chart, that convergence line that we were talking about today. This is the great thing about weather. Everything on the forecast should tie in with things you can actually see. So this weather radar here, that's actually what's physically happening. It's not a forecast, it's what's happening. So if you see rain down there where something was forecast that could provide rain, that gives you a bit of confidence in the forecast. What else have we got? Well, we've got you can get, there's many sources of high resolution images during the day. And this one is one that I use quite a lot. This is a site called Predict Wind, which some of you are familiar with. That's quite nice. That gives a couple of different options and puts it in a picture format, which is always a nice way of doing it. And then there's another one there, that's Wind Guru, that's saying what's going on during the day. And as you can see, all the things we've looked at so far give the wind coming in from a little bit north of east, sometimes a bit stronger, sometimes a bit weaker, but that's what we're doing. So if we look at this with reality, in comparison to reality, this is a very nice, very useful site. This is called Windicator, if you want to have a look at that. And this has all the weather stations around the country. Very useful. Again, winds coming from just north of east, just like that. Another really good one. There's tons of information out there. This is Windy. This is a really nice site here. It gives a good representation. They use good quality data, and you can get different sources of it as well. So anyway, how do I do all this? So as a meteorologist, it's my job to look at all of this and try and distill out the information that's useful for the sailors that I'm forecasting to. I'm forecasting for. So how does it all work out? What's a good, efficient way to do this? Because if you're going sailing for the day, or just going outside doing something, you don't want to spend all day getting a forecast. That's not the point. That's my job. What you want to do is be able to get a forecast quite quickly. And the first step in that is always go outside and have a look at the sky. This is what it was at 0800. So about half an hour after dawn this morning. It's got 3/4 an hour after dawn this morning. And it was a beautiful, beautiful morning. Hardly any sky at all. One interesting thing, though, and this is like looking out west. You can see down here, just above the land, you can see where my mouse is moving up and down there. What looks like a sort of a dusty layer, and that's exactly what that is. That's that lower layer of air there, because it's close to the ground, has been kept cool because the land gets really cold overnight. So that's cooler than the air above it. So that basically traps in dust, and that's called an inversion. And what that means, as you're standing there with your cup of tea in the morning, you can look at that and you think, okay, I've got an inversion. That means the bottom layer of the atmosphere, where we sail in, is nice and stable. So not much is going to change there until everything warms up a little bit. Well, I'll come back to that later on. So that's the first thing in your forecast is always to look outside. The Mark 1 eyeball and your sailing knowledge, they're very powerful things to use properly. Then go for a detailed forecast. Have a look at what's going on. And I've mentioned the Met Office forecast before, so that's what it is again. And then I quite often use the Predict Wind forecast. But it doesn't really matter which two you use. The important thing is to use more than one. And the reason that is because if the forecast is actually a fairly confident one, and this is, let me just go back a little bit. If you're a sailor or anyone going outside and you're planning your day, you're planning your trip, you're planning your race around the weather forecast, you want to know how much confidence you can have in that weather forecast. Is it a good forecast? Is it rubbish? Because if it is a good forecast, you'll plan your trip, you'll plan your day differently than if it's a rubbish forecast. You have to be more cautious. So basically, if lots of different forecasts tell you roughly the same thing, then you can have pretty good confidence in that. if you look at a few different forecasts and they all tell you different things, then at least you know the forecast isn't that confident. So you don't want to go out on a limb, be it taking a big chance on the race course or doing anything else that you need steadier weather for. So that's the first thing. That's one of the important things is when you are looking at forecasts, use more than one and just see if they vaguely agree or not. If they do, probably going to happen. If they're completely different, then it's up to you again to use your mark on eyeball to see what's going on out on the water. The chart I've got up on the screen there, that it looks really high resolution, but you've got to be a little bit careful of it. Back in the last Olympics in Rio in 2016, the bay there itself was surrounded by land. Here's a brief map of it. There's the coastline there, the south coast of Brazil, and here's the harbour entrance and the big bay, which is called Guanabara Bay there. And the sailing happened, it was outside there and inside there. And this map here, that's a representation of how high the land is. So the more dark brown it is, the higher it is, and the more green it is, the lower it is. So you can see that Rio's surrounded by this big rectangle of mountains. So this particular model was used by one of the respected commercial weather companies to give a high resolution forecast, which I did used to use every day because I found the timing very good. If we just zoom in a little bit though, this particular part of the harbour, the yellow circle there is the medal race course. So that's where the final race in each of the Olympic classes was done. So that's where Hannah and Saskia won their gold medal in the 470s. Giles won his gold in the Finns, and Nick won his silver in the RSX, the windsurfers. And if you look at the land around it, let's see what happened. Now, if you've ever seen any photos of Rio, the photo of Christ the Redeemer, the big statue, that's up on that hill there, so that's all good, that works. But if you look around the bay here, you see that bit of land there looks as if it's very flat and very low, whereas actually it's got that sitting on it. It's got Sugarloaf, which is this enormous chunk of rock, nearly 400 meters high, but which is actually not very big. It's only a few hundred meters across, yeah. But that's sat right there, where you can just see the pointer on the screen now. So right at what is usually the windward end of the medal race course. So any weather forecast that you got basically says that Sugarloaf doesn't exist, whereas actually it's the single most important chunk of rock for weather in the entire harbour. So when you are looking at forecasts, however shiny they look, however high resolution they say they are, bear in mind that things like that won't be picked up. So you've got to use the information they give you, which is good information, and then you've got to go sub-grid, as I say. You've got to think about what happens around the rocks, around the hills, through the harbour entrances to see how that works in practice. So let's talk exactly about that, and let's go to where we are now. At the moment, I am in the weather shed at the bottom of my garden, just there, in St Justin Roseland, with a cup of tea, obviously. And the red dots that I've got here show the resolution of the Met Office model. Now, the Met Office, the UK Met Office, consistently, in my opinion, and in many others, gives the best quality forecasts for the UK and for other places as well. Their website's a little bit clunky though, but the data is fantastic. So I'd strongly recommend that you do use that. Anyway, let's have a look. If we got weather as we have today, with the wind coming from there, then the Met Office model, their computer model, will give an exact forecast for the wind there, basically an exact forecast for wind and temperature and everything else for each of those dots. However, with the wind coming that way across the harbour, then what's actually going to happen in reality? We know that down here, coming up to St Anthony Head, that bit there is going to be really sheltered. It's going to be very swirly. Similarly, just tucked underneath there, it's going to be really quite sheltered and really quite swirly. Whereas on the other side of the harbour here, that wind is going to come piling across the bay, and basically hits what's a reasonably high hill on the dark side, on the west side of the harbour. And it's going to bend and follow the shore and be accelerated slightly as all that wind gets pushed down through a smaller area. And that sort of effect doesn't get picked up by the models because it's just too small. But however, as a sailor, you can look at the forecast and think, oh, okay, the wind's coming from there. Oh, I've got a cliff there, or I've got a big bunch of trees just directly to windward, or there's a river valley that's going to funnel it out. And you can make a really good guesstimate, an educated guess of what the wind is going to do in some detail on the water. So that's a really good thing to do. Just as another example, this is from Storm Doris a year or two ago. And this is at Portland, where the British sailing team trains. You've got coming through the harbour. In this particular day, we had quite a strong west-northwesterly wind, about 23 knots. It would have been gusting more than that. But round Portland Bill here, it was 41 knots, excuse me, which is nudging force 9, and gusting 58, which is force 11 at least. No, it's about force 10, force 11. I can't quite remember the details. So the wind in general in that area was the same. But for those of you who don't know Portland Bill, who've not seen it, it's really quite a big lump of rock. And the wind can't easily go over it, so it has to go around the edges. And as it goes over the edge, as it goes around the edges, it gets accelerated as it squeezes through the gaps. So just another example of how the forecast will change depending on the specifics of the land that that the wind actually blows over all around. So if we've got our forecast for the day, whatever it may be, what you need to have an idea of is how that's going to change during the day, and what you might see to give you a clue that something is about to change. So this is not the weather that we have today. This is the weather that we've had a lot in over winter, basically. And what I'm looking at here is it's a side view of a low pressure system, and we've had loads of those come over this last few months. And generally, what happens is ahead of your low pressure system, you have cold air, relatively dry, so you can see from it for ages. Not many clouds. Then you'll have this warm front arrive, sort of a line of not very heavy rain. Then there's a warm sector behind that where it's quite cloudy, occasionally showery. Nothing really changes that much. Then you have the cold front, which is generally where you have your line of squally showers or maybe thunderstorms. And then behind it again, you have you know how it is when the squalls go through and you have this beautiful clear weather behind it. It still may be blowing strong, but it's really clear. So that's your typical progression of a depression, of a low pressure system going through. So let's say you had one of these in your forecast. Now, from a sailing point of view, it's quite important to know when the front arrives, because normally you're generally in the northern hemisphere where we are, every time you have a front going through, normally the wind will veer to the right. So if your wind was southerly, it'll maybe veer to the right. It'll go right to be southwesterly from the southwest. So that's quite important to know as a sailor, because if you have a 20-degree wind shift, it can make all the difference if you pick it right. So what you could do is you could look at the forecast. You think, right, I think at 2:30 the front's going to be here. So from about 2:20 onwards, I'm going to make sure I protect the right. I'm going to be over there. I'm just going to see what goes on, and I'm going to catch that because I know it's coming through at 2:30. That's not a good way of doing it. Because what normally goes wrong in forecasts these days, forecast quality these days is pretty good. But what normally goes wrong, the thing that most often goes wrong, is the timing of the forecast. So things may come through a bit quicker or a bit slower. So the thing to do, if you have, say, this in the forecast, is to just understand in your own mind what you might see. Because if let's say you were sailing down there, so you're a few hours before the warm front is supposed to arrive. The weather's quite nice, but like it is now today, quite dry air, not many clouds around, depending where you are in the country, and all quite nice. But what you'll see during the day with one of these things coming in is you'll start off with high wispy clouds. That's the cirrus clouds up there, and they'll often be coming in from a bit to the right of where the wind that you're in now is coming. Then over the next few hours, you'll see the clouds get lower and a bit thicker and a bit darker until you start to get quite low clouds with a bit of showers coming in. And then the warm front will come over. So if you've got this in the forecast and you're thinking about when's it going to come, keep an eye on the clouds, because they'll tell you. If the clouds are still high, then you've got hours before it arrives. If they're getting lower and darker all the time, then it's on the way. So that's a much better way of getting your timing right than thinking, well, the forecast said 2:30, so it's not 2:30 yet, I'm not going to bother. Really important to understand what your forecast will show you in the sky and the clouds and things like that, and relate that to reality. Just so the same thing happens with the cold front there. So if you're sailing in this bit here, it'll be generally fairly steady, a fairly uniform layer of stratus cloud, maybe a few patches here and there. And the wind will be fairly steady. You might get the occasional shower, but nothing dramatic. And then you should see this line of deeper, darker clouds coming towards you, and that's the cold front. Again, that will, in the morning, that will have been forecast for a particular time, whatever it may be. But you know that with a cold front, you will get this line of squall clouds. So until that comes through, there's no point in really worrying about it. If you can't see them, then the cold front isn't there yet. So rather than looking at the forecast time and thinking, right, at 2:30 I'm going to be doing whatever, think of what the forecast means in terms of what you can see, or maybe in terms of how the air feels. Does it get colder? Does it get warmer? That sort of stuff. And use those as your cues for when the forecast is actually going to come through. This is quite a large scale thing. It also happens on a smaller scale as well. This photo was taken a couple of years ago at the Hier's Regatta on the south coast of France. And we just had a wind change. And up until about 20 minutes earlier, there'd been a cloud, sort of what we call a banner cloud, in other words, one that stays there even though the wind's blowing, on that hill just there. So what had been happening is we had a wind coming, an onshore wind, just coming onto the shore, and the wind had been pushed up over that hill, which meant that it was basically forming a cloud at the top, and that cloud was always there when the wind was coming from that direction. We were expecting the wind to veer to the right, and when it did so, that changed it from being a wind that was coming onto the shore to a wind coming off the shore. And what that means is that the air itself actually gets drier, because if you have air going over the sea, it picks up more moisture, whereas if you have air coming over the land, it doesn't pick up moisture because there isn't much. So what happened was that cloud disappeared. And then about 15, 20 minutes after that, we had the wind shift onshore. So that's another thing. If you are expecting a wind shift, and it's not to do with the front, just have a think. When you first go out sailing, just look around and see if there are any cloud features which seem to be fairly constant, and just note those. And if they do change, then you think, oh, hang on, the clouds changed. That means I must have different air going up into that spot. Something's going on. It may just be a cloud, but there's a good chance that it does have some information that you as a sailor can take advantage of. Okay, so that we've been talking about where the wind comes from, how you can work out that sort of stuff. But also the nature of the breeze is very important. If the wind's very steady, then you'll sail differently to if it's all puffy and shifty. And you can use the nature of the clouds to really give you some help with that. The two pictures I've got on the screen here, the one on the left is a satellite image, and on the left of that picture, you can see it's almost like a honeycomb structure. That's very typical of cumulus clouds over open ocean. And basically, you can see how the cloud pattern itself is quite scattered. So, what is a cloud? A cloud is a collection of water droplets. That's all it is. And what holds it up there? Well, it's not electromagnetism or anti-gravity or anything like that. All it is air going up. So if you have a cloud, what that means is that there is air physically rising upwards, and that's holding those water droplets up there, and that's what keeps the cloud up there. So if you have air going up and it produces a pattern, as you can see on that cumulus cloud arrangement there, then you've got a sort of a scattered pattern of air going up, which means you have a scattered pattern of air going down. So the wind underneath here would be more puffy, more shifty. You'd be going left and right a bit, more than normal. Whereas the photo on the right, obviously I took that out of an aircraft window. I was on the way to Palma last year with this, and it was a stratus cloud. I was getting quite excited about this. I'm just the most boring person to sit next to on an aircraft. Anyway, don't let me have a window seat. I'll be pointing out clouds of really exciting things to do with weather the whole trip. Anyway, what you can see here is that there's big, long rolls of cloud. So each one of those rolls, which you can't see from underneath, it just looks like a big, flat, grey layer of cloud. Is because there's more cloud stuffed up in those rolls. That means there must be slightly more air going up under them, which means you'll have a big, long pattern of you'll have bands of gusts on the surface as opposed to little puffy things. So even if you do have a stratus cloud, which looks really uniform, on the top side of it, it's normally something like this, where you have these big rolls of cloud up above there, which is why you often get bands of wind coming out underneath stratus clouds. And this is another shot of taken when I was walking the dogs a couple of years ago. Genuine Cornish sheep over there, but this is mostly broken stratus, so reasonably steady. But you're still going to get bands and large patches of gusts underneath it. Basically, your clouds give you an almost direct view of how the air is rising up. So if you can see it rising up in a certain pattern, then you can basically say it's going to be coming down in a similar sort of pattern as well, which again can allow you to make decisions as to how you sail your race. So we've also all had moments of more or less terror when you get caught by a squall cloud coming through and it changes the weather dramatically around you. Let's just have a look at this. Generally, this is now looking from above, and the normal wind is blowing from the top of the screen down to the bottom. That's the gradient wind. That's the blue arrow there. So, and then the wind around a cloud is going to be affected, as you say there. If you're upwind of the cloud, there's normally less breeze. If you're downwind of the cloud, then you get the breeze. You get gusts from the cloud adding to your normal wind, so you get more wind down there. And if you're to one side of the cloud, the air tends to move away from the base of that cloud. For those of you who are potentially mums and dads, if you're watching this afternoon session, I'm going into that in a bit more detail, a bit more background on that. But anyway, if you're sailing upwind, if the cloud is going to pass in front of you, then as you get up to it, you're going to get headed. You're going to be pushed further downwind, further away from the wind. So tack, take the lift on the opposite tack. And then when you're back out of the influence of the cloud again, which can often only be between 50 and maybe 200-300 meters tops. This is all really small stuff, small scale stuff. Then you carry on back on your original course. However, if the cloud's going to go over you or just behind you, then you're going to get more wind. So if you may have to sheet out a bit and just basically heel over more, hike. But as the cloud goes behind you, you will actually get lifted. So you can take the advantage as you do get briefly lifted, and then sail back again when you're back into the normal gradient wind on the other side. So that's what happens when you're going upwind. When you're going downwind, again, it's very different if the cloud is coming on your upwind or your downwind side. So here we are, the cloud's just coming in between these two boats. That one there, the cloud is on its windward side. That one there, the cloud is going to come down its downwind, its leeward side. So as it moves there, then the boat with the cloud to windward will actually be pushed further downwind, effectively be lifted downwind, whereas the one on the other side will actually be headed. It'll go slightly further away from where it was trying to go in the first place, and then it'll move as the cloud disappears. As the cloud moves further downwind away from you, you get back into the gradient wind again. So, and this is a fairly simple example, but it does actually work. And if you can get similar things with occasionally you'll get sort of trains of these clouds, lines of the clouds. So you can use those to give you a shove left or a shove right if you know what you're doing. So, what I've got something for you to do today. I've got a bit of a job for you to do. I need you to go and look outside. I mean, just look out the window for now. But during the day, I'd like you to just have a quick look at what's going on. So if I show you what's been happening here, this is the photo that I showed you at the start. This was at 8 o'clock in the morning. Beautiful clear sky. A few little cumulus clouds over there, and probably the most significant weather feature is this inversion, that low dusty layer that I spoke of. Just an hour and a bit later, 20 past 9, there's no inversion anymore, and that means that the land has warmed up enough to be able to break out of that inversion layer, and so the circulation, there's vertical mixing going on now, and you've got these little puffs of cumulus coming up. Whereas, and then just a little bit later, about an hour or so ago, excuse me, the clouds are getting bigger. So we'll now have bigger patches of gusts and bigger lulls across the water. So what I'd like you to do during the day, please, and this is obviously not compulsory, but if you're looking for something to do and something to think about, which may help your boat go faster next time when we can get back on the water. First of all, have a look. Work out the forecast for where you are. Just look at the information you can get either online or on the telly or whatever, and just have a think about what the forecast is for where you are. Then take a couple of photos. Go outside or out the window if that's what you've got, and just take a couple of photos, or take as many as you like. I encourage people taking photos of the sky. If anyone ever nicks my camera, they're going to get 10,000 photos of clouds and probably about 4,000 photos of spaniels. But anyway, take one at midday, about 12 o'clock, and another one 3 hours later at 1500, at 3 o'clock in the afternoon. And just what I really want you to think about is there any difference in the cloud pattern? Has it gone from being very patchy to complete cover or whatever? Is there anything going on? And with that, how do you think that would affect the wind at surface? Now, if you have any questions or you want to send your photos in, please do. The British Sailing Team social media feeds are all there, and if you could use the hashtag sail from home, then do send them in. Love to see them. I will answer any questions or queries or whatever. Just have them coming in through our social media streams, and enjoy the clouds. Cloud watching is a good thing, and you can do it quite safely. Stay safe, everyone, and I will hopefully see you on the water soon. Thank you very much.